Okay, so I was just about done. 2 over 2 is the same as 1. So x equals, and then 10 over 1 is like 10 wholes. So this is 10. So x equals 10. And then we can check it with the original equation, which is 1/2 of x equals 5. So this is 1/2 of 10. 1/2 of 10 equals 5. Well, what is half of 10? Half of 10 is 5. So I know that this is true because 5 equals 5, and that's how I check it. Okay, using multiplication for division problems is trickier because now we've got to do, you've got to actually do it. You can't just guess and check. You have to do the practice work. You have to do the inverse operation. Okay, I'm going to pause. I'm going to start a new page, and we're going to do another problem. Okay, this problem is 2/7 of x equals 6. So again, just like before, I have to use the inverse. Okay, so I need to find the inverse. So I started with 2/7. The inverse of 2/7 is I'm flipping the numerator and denominator. Okay, so I'm going to flip them. So I get 7 over 2. I am using a fraction coefficient, so I need to use the inverse. Okay, so now I'm going to multiply by the inverse. So I'm going to multiply by 7 over 2. But since I did it on the left-hand side, and this is an equation, which means it's equal, I have to do it on the right-hand side also. Okay? Now, in the last one, I kind of just put my whole number over 1, and I forgot to explain about it. Remember, if you have a whole number like 6 or 5 or 8 or whatever, it's just 5 over 1 or 6 over 1 or 8 over 1. Whole numbers are written as fractions by putting them over the number 1. Okay? So then now on the left, we're going to multiply. 7 times 2 is 14. 2 times 7 is 14. And then I've got an x equals 6 times 7 is 42. 1 times 2 is 2. Okay. Now I'm going to simplify. 14 over 14 is the same as 1. And 42 over 2, this is a division problem. Division. This says 42 divided by 2. Okay. That's what fractions are. They're all division problems. What is 42 divided by 2? Well, 42 divided by 2 is 21. Okay. So x equals 21. And we can check it by plugging it into the original equation. So 2/7 times 21 equals 6. So then I'm going to put 21 over 1, just like I do for all fractions, all whole numbers when I want to write them as a fraction. This becomes 42 over 7 equals 6. And then I've got this fraction again. This is 42 over 7. What's 42 divided by 7? Well, 42 divided by 7 is 6. 6 equals 6, so that's true. Okay, checking your answer when you have fractions is a little harder than before. That's why it's really important that you're using inverse operations and you're not just guessing a number that you think will work. Okay, when I look at this problem, I have no clue the answer is 21. I don't know. That's why you have to use inverse operations, okay? I'm going to do one more, and it's going to be a little bit easier. This one's just going to be W over 4 equals 12, okay? Now, this one's a little easier because I don't have a fraction in the front, but it's also harder because of the way that this is set up, okay? W over 4 is basically saying I have a W, and I divided it by 4, and it's equal to 12. Okay, because remember, fractions are division. Okay, fractions represent division. So since fractions are division, what is the inverse operation of division? The opposite of division is multiplication. Okay, so then I'm going to multiply. So I had W over 4 equals 12. So what I'm going to do to solve this problem is I'm going to multiply by 4. So I'm going to rewrite it. W over 4 equals 12. And I'm going to multiply. I'm going to use a second video.